Another aspect, I'm wondering about here, when it comes to multi-axis electric motion control, is it better suited for longer distance motion applications or shorter distance applications, or does it matter?
It really doesn't. The answer is all of the above. So we've gone up to some of our longest applications up to 60 meters so far, which is pretty long. I guess technically we could go up to 64, but our factory is 64 meters long, so that's the furthest we can go at this point without cutting holes in the wall.
Okay.
So up until that point, but yeah, so we can go pretty long with the electric, and we can cut those to exact lengths. But we also have some applications where we're moving, maybe 20 millimeters. So it really just depends on what the customer needs, but it's a great solution for no matter how long of a distance you have.
Okay. So any plans to cut holes in the wall to go beyond the 64 meters there?
Not just yet, but if we
Not yet.
come to an application that requires it, they may. So
We figure it out. All right.
yeah.
So, another characteristic, when you're coming to, any discussions of motion control technologies, what about the speed characteristics? How does that figure in with multi-axis electric motion control? And again, in comparison with general electric or pneumatic motion control?
Yeah, with electric, for example, on our side, we can accelerate up to 10 Gs. So we can move pretty quick, go very fast. It kind of depends on the guide systems and the drive systems that we might put into that particular actuator to get those performance levels. But they definitely can move very quick. For short movements, pneumatics perform very well. They've been used forever for very short, quick actuation. So there's definitely, I think, more of the positives or the differentiators between the two when it comes to some of the other things, such as, like I said, the maintenance, the total system cost, reduction of having to have the air and all that stuff that generally comes into a little bit more of the consideration. But when it comes to the speed characteristics, it probably depends a little bit on the payload and the distance that you're trying to move on maybe which one will have a better speed characteristic or performance between electric and pneumatic. But we definitely have some pretty fast applications that require us to move very long distance that electric performs very well on.
Okay. And kind of as a follow-on to that question about speed, it's one that kind of comes in conjunction with it most often. That's accuracy. Can you
Mhm.
comment on the accuracy of multi-axis electric motion control compared with the other technologies we're speaking about?
Yeah, and this is probably one of the key reasons why people have been looking at replacing pneumatics with electric, especially when they're designing maybe a new system, like an OEM that's building a new system to eventually sell to their end customers. Electric allows for much more precision capabilities than pneumatics, since you're basically just driving a motor, whether it's a stepper or different type of motor. Ours are motor agnostic, so we can pretty much marry up with anything out there. But you're essentially just driving the motor with a PLC or again, a simple stepper. Whereas with pneumatic, there's a lot more effort and time that goes on the setup process to get pneumatic to go to a specific point, and dial that in. And then there's much more maintenance on the back end once that system's installed to keep that running properly. If you have a drop in air pressure, you have a seal that starts to wear, the accuracy starts to go away. So that's definitely one of the big reasons for electric compared to pneumatics, is the ability to quickly get it exactly where you want it and know that it's going to go back to that same place every single time. Electric is extremely good at that. So again, is depending on the guide and the drive combo, we can even get as much as 0.02 millimeters plus or minus accuracy. So we can get pretty good accuracy on that.